Hello, so today I'm going to be working through an A-level question which came up in the 2012 A-level maths paper, and it is a question about straight lines and a bit of coordinate geometry around them. It's quite a common question, come up in question 4, question 5, so it's one of the easier ones, but there are some tricks to it. Okay, let's start off. So we are given a line, L1, and it has equation 4y plus 3 equals 2x. We're told that point A is on this line. And first question, part A, find the value of the constant P. Okay, so that's just some simple rearranging. So we have the equation of L1, which is given. Wherever I see a y, I'm going to substitute in 4, because we want to work out the x coordinate of this point. So I'm going to substitute in 4, wherever there's a y. So 16 plus 3, 2x is equal to 19, x is equal to 19 over 2. I'm going to leave it in fraction form, but you could also give it in decimal form in this case. It's fairly easy decimal. I recommend leaving it in fraction form though. Okay, so p is equal to 19 over 2, and that's the answer. Fairly easy, warm up to the question. Okay, part B. The line L2 passes through the point C, which has coordinates 2 and 4, and is perpendicular. That is important to L1. Find the equation of L2, giving it in this specific form. Alright. Okay, because it's perpendicular, we know that its gradient is the negative reciprocal of L1. So we know the property, the gradient of line 1 times the gradient of line 2 is equal to minus 1. This is true when perpendicular. I'm just going to draw this little symbol to represent perpendicular. Okay, so I'm going to take L1 and rearrange it into the form y equals so we can get the gradient. So L1 is 4y plus 3 equals 2x, and I'm going to rearrange so that we have a y equals form so we can work out the gradient. And it shouldn't be too hard. I do have a video on rearranging. If you're a bit unsure, you can go check that one out. Okay, so we have the gradient, which is the coefficient of x here, and that is a half. So let's take the negative reciprocal of a half, and that turns out to be 2. Flip the fraction, add a negative sign. This is a little piece of information they expect you to know for these 5 marks. It's not hard. Maybe you just have to do a couple of questions and it will always stick in your head. It is GCSE knowledge, however. Okay. What isn't GCSE knowledge is the equation, not formula, for a straight line, which will come into effect here. You don't need this formula, but it does make your life a lot easier. So, y minus y1 is equal to m bracket x minus x1. So, this looks hard, but it really isn't. So, x1 and y1 are just a point on this line. And we're actually given a point on this line. And this is why I know they expect you to use this formula. You don't have to, but it makes your life really easy. Okay, so C lies on this line, and C is 2, 4, given on the question. Now I'm just going to substitute, because we have m as well. So I'm just going to start substituting. Y minus 4, which is the y coordinate, is equal to minus 2, which is the gradient, x minus 2, which is the x coordinate. So y minus 4 is equal to minus 2x plus 4. And then I'm just going to write it over here. Y is equal to minus 2x plus 8. And then rearranging, so we have everything to one side and making it equal to 0. Y plus 2x minus 8 equals 0. Okay. So now that we've done part A and part B, we're going to do part C. And that is to find the intercept between L1 and L2, which is point D, and state it as coordinates. Yeah, this is the last step that some people do forget to put it in the coordinate form. So we want to end up with an answer that looks like this. Right, so from the first parts of this question, we found out that L1 has equation y equals a half x minus 3 over 4. And there is a reason I'm putting it in these form. So we found out that y equals form. And we also find out that L2 is equal to y equals minus 2x plus 8. And we found this out just before we put it into this form here. Okay. So we actually want to make them equal to each other, because if you look, they're both equal to y, so I can actually substitute them in and just make them equal to each other here. And that's how we're going to find a point of interception. So by doing this, we've kind of solved, they're kind of like simultaneous equations, if you really think about it. And I'm solving them by substitution. So now I just want to rearrange so I can find the x coordinates of this coordinate d, which is the intercept. Okay, so I'm just going to add 2x. 2x is also 4 over 2, so 5 over 2x minus 3 over 4 is equal to 8. And then 5 over 2 x is equal to 8.75 if we want to do it in this form. We could alternatively do it in a fraction form, which, doing it in my head, would be 35 over 4, I believe. Yeah, 35 over 4. Let's actually keep it in this fraction form. So then 5 over 2 x is equal to 35 over 4. Let's multiply by 2 so we get rid of the fraction part on the left. Multiplying by 2 like this. We can just use a calculator for this part. And then dividing by 5. Let's see, 35 divided by 2 divided by 5, 7 over 2. So we found the x coordinates. We can leave in fraction form. Usually that's what the exam boards want. But now we have to find the y. So now I'm going to go back to one of these equations here, and we can use any of them. I'm going to use the bottom one, so I'm going to use L2, just because it doesn't have any fractions in it. And I'm going to substitute an x, so y is equal to minus 2 brackets 7 over 2 plus 8, expanding out those tiny brackets there, minus 7 plus 8, so then y is equal to 1. So d is 7 over 2, 1. Okay, so then part D is quite simple actually. So we want to find the length of CD, and it actually gives us the answer so we can know if we're right or wrong. So CD should be 3 over 2 square root times square root of 5. Alright, so we are given C in this part of the question here. It's 2 over 4. And we worked out D from the previous question as being 7 over 2. Comma 1. I'm actually just going to write 3.5 because it might be a bit easier to work with decimals in this case. And to find the length of a line, we take the square root and we find the differences between each x and y. So just like Pythagoras' theorem, it actually just is Pythagoras' theorem. So I'm going to take, I'm going to start with C. Doesn't matter because they're getting squared. So 2 take away 3.5 squared plus 4 take away 1 squared. You might want to just simplify it a little bit. So then 2 take away 3.5 is minus 1.5. Minus 1.5 squared is 2.25. And then 4 minus 1 is 3 squared is 9. And then adding these up, you get the square root of 11.25, which if you put into your calculator will give you 3 over 2 square root of 5. Okay, so moving on to the last question, which is probably it is the hardest question of this question, if that makes sense. And that's probably what's going to set A-star students from A students apart. Okay, so let's start reading the question. So a point B lies on L1 and the length of AB equals root 80. And we're told about L2 as well. So actually, I'm just going to draw a graph to start off with, and I'm going to plot both of the lines. not perfectly, just kind of eyeballing it. So L1 is a half gradient, something like this. Doesn't matter how straight they are, but as long as it's workable for you. And L2 is a steeper negative gradient like this. Okay, so this here is L2, this here is L1. Okay, cool. So a point B lies on L1 and the length of AB is equal to root 80. So A we actually worked out in the very beginning up here. And we worked out that it was 9.5, comma 4. So it's somewhere here, let's say. A 9.5, 4. And then we are told that B is root 80. Now we don't actually know which way B is, so I'm just going to draw, but I'm going to put B around here maybe, question mark, and around here. There's the other, I know it's a bit different, but it's because I'm kind of running out of space to the right. So it doesn't much matter as long as it's workable. They're not going to judge your graph. Okay, so it's all this root 80. Let's just keep that piece of information there for a bit. And let's work on L2. So the point E lies on L2 such that the length of the line CDE is 3 times greater than the length of CD. So we actually know both of these points, so CD. So we worked out that length CD actually, and we are told that C is 2, 4, so I'm going to put that one on around here. C 2, 4, and then D is the intersection point. I'm going to draw an arrow pointing to it. And we worked out that it was 3.5, 1. Perfect. So now we just need to put E somewhere. So the line CDE is 3 times greater than the length of CD. So CD is this line here, and CDE would put E somewhere around here. So E. Alright, perfect. Okay, so there's a little bit of understanding to know about this question. A lot of you might be interested in finding the coordinates of B and E. And I know it would probably be the first thing I would try before I realize that I'm going wrong. But actually we don't need to do that. Because if we split this shape here into 2 parts, into 2 triangles, which we already know the lengths of some sides of, or something like this, we can actually work out the area. So we can work out the triangle ABC and also the triangle BAE because of the lengths we are given. So first of all, we actually need to know the length of CDE to work out the length of DE. So we're told it's 3 times the length of CD. So CD is actually given in question D. You didn't even, if you didn't get that far, we can actually just take it. So CD is equal to 3 over 2 root 5, and then CD is 3 times that, so then CDE is equal to 3 times that, so 3 over 2 times 3 sorry, is 9 over 2 root 5. So this big line here is length of 9 over 2 root 5, but we do want to find DE, so we actually just take away the original length, or just multiply by 2 to start with. I'm taking it just a little slow, so that would be 6 over 2, which is actually just 3 root 5. Nice, easy, third. And that is length of DE. Okay, so CD is the height of the triangle, and obviously area of a triangle is a half width times height. So we've got the height, and the width is actually also given in the question as AB root 80. So that's where that bit of information will come in. So the little, let's call it triangle BCA is equal to a half times the width, which is this root 80 part from A to B, times the height, which is 3. No, actually the height is CD, so it's 3 over 2. root 5. So we worked out this triangle. So actually, we did a little bit of working out. Maybe we could have done this the other way around. Doesn't much matter. Okay, so now if we put that all into a calculator, we should get a fairly round answer actually, and we do. 15, and that's usually when you know you're going right, is that your answers tend to be fairly simple numbers. Okay, so that's this big triangle here done. Now we need to do the triangle BAE. Now we worked out DE to be 3 root 5, and the width is the same, which is BA, so root 80. So that is a half times root 80 is the width, and then the height is 3 over 5. We put that all into a calculator, and we get 30. Adding them together, 30 plus 15 is equal to 45 units squared. We probably want to label this add both triangles. Or if you want to go the long way around and use this B here, it would work out the same. You would have two triangles like this. Works out to be the exact same. A little harder though. Well, that's it for this video. I hope you understood what I'm trying to explain. Message me anywhere on my website or on the comments below if you want me to do any A-level maths, GCSE or further maths questions, and I can hopefully run them, make a video on them, or maybe give you some lessons on any of the topics. Anyways, thank you for watching, and I will see you next time.